Number 29 says simplify the radical. I'm looking for a cubic root, so I'm looking for three like factors. In order to be able to take the cubic root, I have to have whatever the index here is, that's how many of them I have to have. So I'm going to factor 24 so that I see a perfect cube number and then whatever's left over. 24 is 8 times 3 and 8 is a perfect cube, so that's how I'm going to choose to factor it. Now if you don't recognize the perfect cube factor in there, then fully factor it. Factor it down to prime factors, and then you can look and see, are there three of any of the same factors? Okay, if I had done that, that would have been 2 times 2 times 2 times 3 after I factored it. That's what I would have gotten. If I put that under there, I would recognize I have 3 2's. And of course, 3 2's is 8. Okay, now I'm going to take my variable's power, and I want to make the closest multiple of 3 to 14 that I can. And that's going to be 12. And then I write the leftovers. So x to the 12, x squared. 12 and 2 is 14. 12 is divisible by 3, so I can take the cubic root of that more easily. And I'm going to do the same thing with y. 6 is a multiple of 3, so I have y to the 6th and 1 left over to make y to the 7th. Okay, so now I've got everything set up so that I can take cubic roots. The cubic root of 8 is 2, so that comes out. The cubic root of x to the 12th, remember you take this power and divide by the index. 12 divided by 3 is 4, so x to the 4th comes out. I'll cross these out. I used that and I used that. So now I can't take the cubic root of x squared. There's only 2 of them. I'd need 3 of them. Y to the 6th, the cubic root is y to the 2nd power, because I said 6 divided by 3 is 2. I used that. So anything I didn't use stays underneath. So I have a 3. Can't take a cubic root of 3, so that should stay there. I have an x squared. Again, can't take a cubic root of only 2 terms, and the y stays there. So now, do I need to consider on this whether or not I need absolute values? And the answer to that is no, because I took a cubic root. And remember, the rule is even. What's underneath is even. What came out is odd. Well, what came out was even. What my index was odd. So no consideration for whether or not that needed an absolute value. Okay. B says the fifth root of 96 x to the 38th y to the 6th over the fifth root of 3x to the 6th y to the 21st. Well, I have 2 separate fifth root problems, so I'm going to combine them into one. I'll do that over here. That gives me 96 x to the 38 y to the 6th over 3x to the 6th y to the 21, and that was a fifth root. I combined them because this is divisible into 96, and of course the x's and the y's are as well. So now I'm going to come down, and I have still the fifth root. 96 divided by 3 is 32. X to the 38 divided by x to the 6th. Remember, the quotient rule for powers is subtract your exponents. 38 minus 6 is 32, so I have x to the 32 over, here my greater exponent is in the denominator. I'm going to say 21 minus 6 is 15, and of course it goes in the denominator because the bigger one was in the denominator. Make sure that looks like it goes over all of that. Okay, so next step, I want to figure out if each of these has a fifth root, or if it's a perfect fifth power. Well, 32 is 2 raised to the fifth power, so that is. X to the 32 is not, though. I need this to be a multiple of 5. So I'm going to go to my next step. And I'm going to make that x to the 30 x squared. The rule, to make this easier, you take this number and find the closest multiple of 5 to 32. That's 30, and then the leftovers. Of course, 15 is divisible by 5, so I can leave that, y to the 15th. Let's extend the page a little bit. Okay, so now I'm going to go ahead and take my fifth roots. The fifth root of 32 is 2. the fifth root of x to the 30. Remember, the rule is 30 divided by 5, so that's x to the 6th. I can't take the fifth root of x squared, so that's going to stay under there. I use that one, they're gone. Now, I'm going to take the fifth root of y to the 15th. 15 divided by 5 is 3. That's y cubed. And then what's going to go under my radical is what I had left there. I used that one. And that's x squared. So I end up with 2x to the 6th over y cubed times the fifth root of x squared. I could also write that, let's extend one more time, or 2x to the 6th times the fifth root of x squared over y cubed. Either one of those is an acceptable answer. Okay.